Okay, this is your chapter 8, section 4 practice sheet on algebraic equations where variables are on both sides. The first 4 questions of this particular small, short little quiz are true and false. So the first one says 0.5x is the same thing as 1/5 x. And the answer is false. And on your test, if you were to prove why, you would say that 0.5x is actually equal to a half of x, not a fifth of x. Or you could say a fifth of x is actually equal to 0.2x. Either of these explanations would be sufficient to prove your point as to why it's false. But I can't think of another one that you could use instead. So the answer is false, and you can either have this example or this example to prove why they are not the same. Your second true-false gives you a algebraic expression set up with the multiplication of -2 by a binomial of x minus 5. And the expansion, it says, is equal to this particular here. And the answer for this one is false as well. And the reason why it's false, if you expand multiplying both terms in the bracket by -2, -2 times x is indeed -2x, so that part is right. But the next part, -2 times -5, is a positive 10. So what you should say is that this is equal to -2x plus 10, not minus 10. Remember that when you multiply a -2 by a -5, it's a positive 10. Your third question, true false, says 2/5 x is equal to 0.4x. This is your first true statement. And because 2/5 is equal to 4/10 and 4/10 is equal to 0.4, if it was my proof, that's how I would prove it. I would show that 2/5 and 4/10 are equivalent fractions, and therefore 4/10 written in decimal form is decimal 4. And finally, your last true and false says half of x plus 1, or x plus 1 divided by 2, is equal to half of x and a half. And the answer for this is true. And I don't think we've ever formally talked about it, except in chapter 7. We said when you divide, in this case, a binomial by a monomial, you must also use distributive property. So you have, not only do you have x divided by 2, but you have 1 divided by 2. X divided by 2 would be this, or half of x. And 1 divided by 2 is simply a half, or 0.5. So therefore, it is true. It equals half of x and a half. Okay? And you would probably prove it if it was me. I might utilize something like that to show that you're dividing both terms in the binomial by 2. Your next questions are simply isolate the variable. In the first question, you have -2x minus 10 is equivalent to 3x. So in these situations, you were told that usually it's easiest to get rid of the variable or the algebraic term on one side that has the least amount of the variable. So in this case, adding 2x would be your best bet. You don't have to do that. You could actually add 10 to both sides if you wanted. You could remove 3x from both sides if you wanted. But the shortest path, or the path of least resistance, is to add 2x to both sides. That creates an algebraic zero pair, leaving you just with -10. And when I combine 3x with positive 2x, I end up with 5x. Once you have that, you simply have a one-step algebraic equation, which would divide both sides by 5, and x will equal -2. Your next question says 5x is equal to 6x plus 4. So here's one of those interesting situations where when I told you to remove it from the side that has the least amount, it's actually not the most efficient way to do it. You still can do it. So if you subtracted 5x from both sides, you end up with 0 is equal to x plus 4. And then you would simply subtract 4 from both sides and get x equals -4. Alternatively, if I was to take this 5x equals 6x minus 4 plus 4, if I was to subtract 6x from both sides, I would end up with a -x is equal to 4, which seems like it's done, but it's not because your coefficient's -1. Divide both sides by -1, and x would equal -4 too. So either way, it didn't matter which one you did first. You could subtract 5x from both sides. You could subtract 6x from both sides. But when you're done isolating the variable, you still end up with the same answer of x is equal to -4. Your next question says half of x plus 3 is equal to 3/5 x. The easiest way to do this, in my opinion, you could subtract a half of x from both sides if you wanted. So subtracting a half of x is going to get rid of this one. And subtracting half of x from this requires a little fandangling, because what you're doing is you're really combining the coefficients. So if I think about 3/5, take away a half, common denominator of 10, I have 6/5, take away 5/5, I get 1/10. So when I combine these right here, because they're like terms, I'm really combining their coefficients. I end up with 1/10 as a coefficient, so therefore 1/10 x is equal to 3. Now at this stage, you might want to consider thinking of it like this, because 1/10 x written this way is the same thing as this. And the only reason why I say that is I can divide by a tenth to get rid of the multiplier of a tenth, or I can multiply by 10 to get rid of this. And when I think about it, multiplying by 10 is the same thing as dividing by a tenth, because you're going to change the multiplication by the reciprocal, right? If you divide by a fraction, you multiply by the reciprocal. So either way, you end up with the answer of x equals 30. Okay. Question 8. This looks a lot more complicated than it is. We have distributive property on the left and we have distributive property on the right. Before I start isolating the variable, I'm going to simply expand each using distributive property. I'm going to get 2x minus 1 is equal to 1/4 x plus 1/4. Now that I've expanded it, I realize that I have variables on both sides, and I know I'm supposed to get rid of it by creating an algebraic zero pair. So I'm going to subtract 1/4 x from both sides to get rid of it on this side. Combining these two terms might be difficult for some, but it's not so bad. If I have 2x and a negative 0.25x, combining the coefficients, I'm going to end up with 1.75x minus 1 equals 0.25. I'm then going to add 1 to both sides to get rid of the constant. 1.75x is equal to 1.25. Did I make a mistake yet? Okay, I didn't. Good. Divide both sides by a coefficient. I have no idea. Sometimes I might make a mistake and no one says anything. X would equal 1.25 divided by 1.75 equals, is that the answer? But is that the answer though? Did anyone get that one? Did I make a mistake? That's good. So your answer is, if I think about this as an actual total answer, 712857, 714825, 714825, 714825, 714825 repeats. So the whole bar goes above the entire 6 decimal places, because those 6 decimal places repeat to infinity. So we're actually going to write it not as an approximate answer. We're not going to round it. It is a repeating decimal, and I can actually see which digits repeat, so I'm going to write it like that. Your story problem question says a jar contains 28 more nickels than quarters. The value of both coins is the same. How many quarters are there? What's the total value of the coins? So the trick is I have to figure out what is my x going to be representing. And when I read this first one, there are 28 more nickels than quarters. So it seems logical that if I make x equal the number of quarters, I would be able to then figure out what algebraic expression would be the number of nickels. And what would that be? If x is the number of quarters and there are 28 more nickels, x plus 28. So step 1 is to figure out which two algebraic expressions represent the number of quarters and the number of nickels. That's step 1. But because we're given this one here, value of both coins are the same. And I'm thinking, okay, the value of both coins is the same. That means I'm going to have an equal sign and two expressions. The number of quarters, or the value of the quarters, is equal to the value of the nickels. I can't use the number of quarters in that equation. I have to use the value of the quarters, and I have to use the value of the nickels. So I got to rethink this. I got to put the value of quarters. So if x represents how many quarters you have, how will I translate that x into the value of the quarters. What will I do to x to get the value? If x represents the number of quarters, what algebraic expression would represent the value of the quarters? Multiplied by 0.25. So if I take 0.25 and I multiply it by how many quarters I have, x quarters, that would be the value of the quarters. And if I do the same thing for the nickels, the value of the nickels, I'm going to take the number of nickels, which in this case is x plus 28, and I'm going to put it in brackets because that's how many nickels I have, and I'm going to multiply that by 0.05, and that will be the value of the nickels. Okay? So step one is to set up your question like that. And here's where we are able to create this equation. And that highlighted sentence, the value of both coins are the same. So what this means is I can take this expression, 0.25x, and make it equal to 0.05 multiplied by x plus 28. This says the value of the quarters is equal to the value of the nickels. And once we set it up as this equation, we can then work towards isolating it. And what do you think the first step is once I set up my equation? What do I have to do first, Dane? I have to expand this over here using distributive property and get myself an actual normal binomial out of it. So this side doesn't change. It's still going to be the value of the quarters is equal to 0.05x plus 1.4, but I'll just show you. So 0.05 multiplied by the 28 equals 1.4. So once we get this black equation, we're like, okay, this is much more manageable. I can see what we're doing here. Oh, I have variables on both sides. I need to get rid of it from the side I have the least amount. I was told that. So I'm going to subtract 0.05x from both sides. Getting rid of it, not just getting rid of the coefficient, but getting rid of the entire term, leave me with 1.4 on this side. And on the other side, because I have 0.25x and negative 0.05x, those are like terms. And when I combine those two, I'm going to end up with 0.20x, or simply 0.2x. All right. From this spot, just divide both sides by your coefficient, because you don't want to get rid of the entire term. You just want to get rid of the coefficient. And you get x equals 7. Is that right? Is that right? No, that's not the answer. That's your x value. Then you got to go all the way back up here. And it says, how many quarters are there? Well, since x equals 7, therefore there are 7 quarters. There are 7 quarters. That's the first part, because x equals 7. And since x is 7, then that's how many quarters are. But it says, what is the total value of the coins? So there are 7 quarters, and just for the record, how many nickels would there be? Just for the record, just for fun, how many nickels are there? If there's 7 quarters, how many nickels are there? 35. Do I need to calculate each value independently, or can I just calculate the value of one and know that the other one is that as well? Because it says here in the highlighted yellow, the value of the coins are both the same, 35 nickels should equal the same value as 7 quarters. How much is 7 quarters worth? $1.75. How much is 35 nickels worth? Has to be the same, even though I'm not even going to think about it. Has to be $1.75 because the value are the same. And your last story problem questions is it's probably the hardest one we have. And it says rectangle A and B have the same perimeter. What are the dimensions of each? So the first thing you have to know is the perimeter of a rectangle is made up of 2 lengths and 2 widths. Or another way to say it is just multiply the length by 2, or double the length and double the width, and you have the distance around the entire rectangle, or 2 lengths plus 2. So the first thing you need to write down is that, okay? And then what we're going to do is we're going to calculate what the perimeter algebraically is by substituting what we know. So this perimeter here of A will be 2 0.75 x's plus 1 and 2 0.5 x minus 1. Right? That's the perimeter of rectangle A. Rectangle B, using that same formula, 2 lengths plus 2 widths, would be 2. The length is, there are 2 of these, And there are two of these. Did this work out? I can't remember the answer. Does the answer work out to be nice and neat, or is it kind of messy? Is it a fraction? I can't remember. So now what we have to do is we have to say that this rectangle A, or rectangle A, is equal to B, or the perimeter of A is equal to B, or 2, 0.75 plus 1, or 0.75 x plus 1, plus 2, 0.5 x minus 1 is equal to, that's the perimeter of A, is equal to the other one. And I'm really lazy, so I'm just going to grab this one real quick. I'm going to group it. I'm going to group it here. I'm going to shrink it down just a bit. Bring it over here. Bring this one over a bit if I can. Does it work? Kind of. Okay, then I'm going to ungroup it. All right, that's lazy. But now we have these two perimeters being equal. Now this looks complicated, but it's not that bad. Riley, what do you suspect the first thing we're going to do here to both sides is going to be? What do you think, Ryan? We're going to expand each of these expressions using distributive property. So I'm going to expand every one of them using distributive property. I'm going to get 1.5x plus 2 plus x minus 2. So if I expand them, that's what I get. Oh, sorry. Is equal to 3.5 plus x plus 5.5 minus 3. So once we expand it using distributive property, we end up with these. What do you suppose our next step is? I don't want to start isolating yet. What do I want to do? I want to simplify both my left and right because I haven't done what to both left and right yet. I haven't collected like terms or gathered like terms. I want to simplify this. I want to simplify that into hopefully a binomial. Gathering like terms, 1.5x and x is going to be 2.5x. A positive 2 and a negative 2 make 0. So the nice thing is, when I simplify the perimeter of rectangle A, I end up with a monomial, 2.5x. When I do the same thing to the next one, a positive x and a negative 3x make a negative 2x, and a 3.5 and a 5.5 make a positive 9. So as weird as this looks, once I gather my like terms, it became quite simple, didn't it? This equation that we have here is not hard at all to solve. What am I going to do to both sides? I'm going to get rid of the variable on one side that I have the least amount by adding 2x, creating a zero pair. 4.5x is equal to 9. Okay? And my final step is to simply divide both sides by my coefficient, and x will equal 2. Now, as complex a question as this is, we're not done yet. Because the question actually says, what are the dimensions of each? So all we now know is x equals 2. So if this length is 0.75x, then 0.75 multiplied by 2 plus 1 is its length, or 1.5 plus 1, or 2.5 is its length. When I substitute 0.5 and x is 2 minus 1, I get 1 minus, 1 minus 1. That's interesting. That means the width of the rectangle doesn't exist. The width is 0. It is. Well, I should have thought this question through before I made it up. Oops. Well. Here we have 1.75 plus 0.5 multiplied by 2, which is 1.75 times 1, or plus 1, which is 2.75. And over here, 2.75 take away 2.75 take away 1.5 multiplied by 2, or 2.7. Oh, we have a negative distance. This is exciting. Minus 3. The width of this particular one is negative 2.5. It actually goes into alternate dimension, right? Its length is negative 2.5. So hopefully on your actual test, I make up better questions than the one I made up here, and we don't have negative distances of length.